The idea of a 2025 English electric Canberra feels like the resurrection of a legend that once redefined high-altitude flight and strategic reconnaissance. The original Canberra was one of the most versatile and successful jet aircraft of the Cold War era, serving as a bomber, reconnaissance platform, electronic warfare aircraft, and test bed for decades across the world. Reimagining it for 2025 transforms that historic foundation into a cutting-edge, high-performance multi-role platform built for modern intelligence, surveillance, strike, and electronic dominance. A 2025 iteration of the English electric Canberra would immediately stand out with its elegant high-aspect wings, long fuselage, and clean aerodynamic philosophy, but everything beneath the skin would be thoroughly modern. Advanced composite materials and radar-absorbent coatings would replace much of the original aluminium construction, dramatically improving strength while reducing weight and radar signature. The airframe would be designed for efficiency at extreme altitudes, allowing the aircraft to cruise well above most air defenses while maintaining long endurance for deep penetration missions. Propulsion would mark one of the most dramatic upgrades. Instead of early turbojets, the modern Canberra would be powered by advanced low-bypass turbofan engines optimized for high-altitude performance, fuel efficiency, and reduced infrared signature. These engines would provide greater thrust, far lower fuel consumption, and near-silent cruise at altitude compared to its predecessor. With these engines, the 2025 Canberra could achieve exceptionally long range without refueling, making it ideal for persistent surveillance or long-distance strike missions across vast regions. The cockpit would be completely transformed into a fully digital combat environment. Large multifunction displays, panoramic touch interfaces, and helmet-mounted display systems would replace analog gauges. Artificial intelligence would assist with navigation, target tracking, sensor management, and threat prioritization, allowing pilots to focus on mission execution rather than raw system control. A two-crew or even optionally unmanned configuration could be supported, with one operator focusing entirely on sensor and electronic warfare management during complex operations. The most powerful evolution, however, would be in sensors and intelligence systems. The 2025 Canberra would be a flying data fusion hub. Advanced AESA radar capable of ground mapping, maritime tracking, and air-to-air detection would be paired with long-range electro-optical and infrared systems for day and night reconnaissance. Signals intelligence arrays would allow the aircraft to detect, analyze, and geolocate enemy radar and communications systems in real time. Combined with satellite links and secure data sharing, the Canberra would relay battlefield intelligence instantly to command centers, naval task forces, and frontline aircraft. Weapons capability would elevate the Canberra from a pure reconnaissance platform into a precision strike aircraft. Internal base and external hardpoints would allow it to carry long-range cruise missiles, precision-guided bombs, anti-radiation missiles for suppressing enemy air defenses, and maritime strike weapons. These weapons would give it the ability to not only find targets but eliminate them with pinpoint accuracy from standoff ranges, minimizing risk while maximizing battlefield impact. Electronic warfare would likely become one of the Canberra's defining roles in 2025. Equipped with next-generation jamming systems, cyber-attack modules, and electronic deception technologies, the aircraft could blind enemy radar, disrupt communications, and open corridors for allied strike aircraft. In a modern war dominated by sensors and networks, this ability to control the electromagnetic spectrum would make the Canberra one of the most strategically valuable aircraft in any air force. Defensive systems would be deeply layered and highly automated. Radar warning receivers, laser warning sensors, missile approach warning systems, and advanced countermeasures would work together to protect the aircraft in hostile airspace. Directed infrared countermeasures could mislead heat-seeking missiles, while towed decoys and digital radio frequency memory jammers would confuse radar-guided threats. These systems would operate almost autonomously, giving the crew precious seconds to focus on mission survival. One of the most compelling reasons for a 2025 English electric Canberra is its potential role as a high-altitude long-endurance platform in an era where drones dominate surveillance but still face limitations. A crewed or optionally unmanned Canberra could fly higher, faster, and with heavier payloads than many unmanned systems, while retaining the flexibility of human decision-making in rapidly changing combat environments. It could serve as a bridge between traditional manned aircraft and future autonomous combat platforms. Economically and strategically, such an aircraft would appeal to nations seeking high-end intelligence and strike capability without the extreme costs of stealth bombers or fifth-generation fighters. Its multi-role flexibility would make it suitable for border surveillance, maritime patrol, counter-terrorism operations, deep reconnaissance, and electronic warfare. In regional conflicts and power projection missions, it could operate independently or alongside larger strike packages as a force multiplier. Visually, the 2025 Canberra would be a breathtaking blend of classic and futuristic design. The long wings and clean fuselage lines would still echo the original jet's elegance, while stealth shaping, flush weapon bays, and advanced sensor housings would give it a distinctly modern identity. Heritage liveries inspired by Cold War reconnaissance units could coexist with low-visibility tactical schemes, honoring the aircraft's past while projecting its future. The legacy of the original English electric Canberra adds enormous emotional weight to this concept. It was an aircraft that dominated the skies of its era, flew higher than most interceptors could reach, and served across continents for generations. A 2025 reincarnation would not just be an aircraft, it would be a symbol of endurance, adaptability, and technological evolution. It would show how a platform born in the early jet age can be reinvented for dominance in the digital battlefield. In the strategic battlespace of the future, where information is as powerful as firepower, a modern Canberra would stand as a guardian of data, a hunter of signals, and a precision striker from the edge of defended airspace. It would gather intelligence where satellites cannot see clearly and drones cannot survive easily. It would shape the battlefield before missiles ever fly. The concept of a 2025 English electric Canberra ultimately represents more than nostalgia. It represents the idea that the greatest aircraft designs are not frozen in time but can be reborn with new purpose, new technology, and new influence. By combining extreme altitude performance, long-range endurance, intelligence dominance, electronic warfare power, and precision strike capability into one platform, the modern Canberra would once again become what it always was at heart, a silent force shaping the outcome of wars from the sky.